Differentiation will be one of the easiest if you can remember these few formulas and few rules. So first very common formula you will encounter is ddx of x to the power n. ddx of x to the power n, and this formula will be n x to the power n minus 1. Okay, I'll give one example here. See, if your function is say x cube, then you will get here n is 3. So what we write is 3 and x to the power 3 minus 1. That means essentially x2. How to remember this? Power multiplied with x to the power will be reduced by 1. So see here, x to the power 3, so it becomes, after differentiation, 3 into x power was 3, it is reduced by 1, so 3x square. If x5, ddx of x5 will be 5 x to the power 4. So it will be frequently used, this formula. Next one, it is the few common use of this formula is if n is 1, that means ddx of x. So if you put 1 here, then what will get? 1 into x to the power, if it is 1, so you get 1 into x to the power 1 minus 1. So that means 1 into x to the power 0, and that means it is 1. So ddx of x is 1. This results to be remembered. One more thing is ddx. So we are frequently mentioning ddx of, like ddx means this is a process of differentiation. This is a operator. This operator working is applied to the function. So now ddx of any constant values, say c, will be 0. Okay. So that why it is 0? So first, as a formula, you remember that ddx of constant value is 0. Because any constant curve y equal to any values in x and y axis, this is a y equal to c curve, and you see that there is a it doesn't make any angle with x-axis, which is, or there is no change in the slope. ddx always gives the change of slope. So as y equal to c curve is parallel to x, so there is no change of x at any point. If you see that there is no change of x, so this gives ddx of c equal to 0. So that means, so as example, see, if you write ddx of 5, you will get 0. ddx of 100, that is also 0. So any constant value, any numerical constant values, ddx will give 0. So ddx of root x. So what you need to do, same way, you try to understand what is the power of x. So if power of x is the x to the half, so that means n into x to the power n minus 1. So what it will give you, half into x to the power minus half, and this minus half, as I told you that if you take in a denominator, so it will be plus half, and this plus half is nothing but root x. So ddx of root x is 1 by 2 root x. Okay, so this is one more formula. So all these formulas I am discussing here, and you will get complete list, and you can download from top4.online. Link is given in the description. Okay, we'll move few more formulas. Next one is ddx of e to the power x, and this is a really interesting function. Differentiation is also gives e to the power x. So there is the only one function who is after differentiation also gives the same function. Okay. Next, we will go to like e to the power x. If in case it is not e, say for example any number like 2 to the power x or 3 to the power x, so we write a to the power x. This will give a to the power x log a. So example is, say ddx of say 3 to the power x. So it will be 3 to the power x log 3. Okay, or better you can write log 3 into 3 to the power x. So that means in a to the power x it is contained, but here a to the power x what we get it that whatever a to the like e to the power x, we get a to the power x, but only extra term is log a. So next, log x is very interesting. Result will be 1 by x. Remember this. If you want to know why it is 1 by x, you know that you have to do from the first principle, and the result will be this. So here what we have discussed here is that all the formulas. So please remember all these formulas, which will make your differentiation very easy. d dx of sin x, you have to remember, okay, the sin x is the trigonometric function, you know that. So here result of 6 trigonometric functions to be remembered. Differentiation of 6 trigonometric function. First one is, you know, sin x, so result we get as a cos x. If we get it from cos x, you will get minus sin x. So please remember, it is not cos x is only sin x, it is a minus sin x. Tan x is sec square x. Cot x is minus cosec square x, and d dx of sec x. Sec x, always remember, see here, you know that cos x is sec x is 1 by cos x, but that doesn't mean that your differentiation is 1 by minus sin x, not like that. Okay, if you derive from the first principle, you will get sec x and tan x. d dx is a differentiation, it's a measurement of slope. Now for differentiation rules, first we take up one form where, so before starting here, we will define very commonly used convention is using u and v. So this u is a f of x and v is also a function of x. So when we talk about differentiation, in many places we refer that u and v, especially for compound functions. So here first rule is u plus v, u and v, and see, okay, this function is defined as a summation of a two function. And so if we do d dx of this, what will be the result? So the d dx, so you remember that this plus or minus, if any, so this d dx can be applied separately on each of the functions. This is the thing you have to remember here. So you do separately for u, and d dx separately you apply on v. Okay, And one more things you can observe is that some constant into u, if it comes up, so this constant k values, sometimes we write c, so this constant part will not participate in a differentiation, and we so keep aside this k and you do only for differentiation of variable part like u. Now let us take example and see that, okay, how, what does it mean. See, u is x square and okay, and say here k is say 5. So for example, your function is given 5x squared. What to do? So you should keep 5 here and only do differentiation of x squared. So x squared differentiation from your x to the power n rule, that formula we apply, then you get 2x. So that means answer is 10x. So this is the way, so that if any constant part is there, any numerical values are there, so you can keep aside from and you do the differentiation for variable part. Variable means where it containing x part. Okay, same. Okay, so take v equal to say sin x. So in this example, if you say d dx of u is x squared and v is sin x, if this is the part is given for the differentiation, so what will do that, you know this plus, that means this operator d by dx can be applied here and separately can be applied here. So that means so this ddx can be applied here and ddx also can be applied here. So that means what you'll write here in next step is write it separately, sin x. So you know ddx of x square is 2x and sin x, ddx of sin x is cos x. So okay, this is the way you have to differentiate. So these two formulas as we mentioned here is, first one is the summation or subtraction of these two functions, or it could be for n number of u plus v plus w, like if as many as functions or the variables are there which are related with plus and minus, so ddx you can apply separately. And this one is very important because many places you will find that your function as a 5x square, 2x cube or 3 sin x, like that. So there, that constant part you should take out and only apply ddx in a variable part. Okay, so that's these two formulas. Okay, now we'll move to the next one, which is a little different. This u and v, when they are now this is u and this is v, their relation is now as a product. Okay, what does it mean? Like see, for example, x square and sin x, this is the function is given and you have to do the ddx of this. So here u and v, their relation is as a product. So if this product is there here, So how to do that? So let us write the formula first. If u and v are there and their relation is product, so then you have to do first you keep u, you don't touch the u, do only ddx of v plus v ddx of u. Basically keep one and do differentiation for other part, plus keep which one you did the differentiation earlier, keep it now and do the differentiation for that other. So this is the way. So you see here, so u and v, keep u, do for this, keep v, do for this differentiation, and there in between plus will be introduced. So this formula is very useful formula. Okay, same way we may arise also in one case is that u by v. What does it mean? Say like your function is given as a x square by sine x. So how to do the differentiation this case? So let us write ddx of u by v. Here you have to remember whichever is in denominator like v, so v will be squared, and then keep v here, do ddx of u, and same thing now give rest for u and do the ddx of v, and in between this sign will be minus. So this is a, in case of product it is a plus, in case of division u by v, so the sign will be minus, and you see here denominator square and then keep denominator, differentiation of numerator minus numerator, whichever was numerator, u was in numerator, so numerator part into ddx of denominator. So this is the formula. So in this case if you apply this formula, so ddx of x square by sine x, if you apply then what will happen? Sine square x here, and then keep sine x as it is, do only ddx of x square, so write it. Then minus, and numerator was x square, keep it, and then ddx of sine x. So it will result in a, this is a 2x, ddx of is a 2x, so you write sine x 2x x square sine x cos x and sine square x. That's all. So this is the way you have to perform the differentiation. So what we have discussed now is, one is this product rule, one is this product rule, very important, I'll mark it, this one is very important, and this one also very important. Okay, so please remember these two formula. So if u and v is related with plus and minus, or as a product, or as a division. One more common formula will be used is dy by dx. Sometimes we need to do dz and dz by dx. So you can remember that dz and dz, okay, diagonally they get cancelled and dy by dx remains. But yeah, basically if okay, let's take one example. With that example I'll explain that to what this rule means actually. So say a function is given, say y is a function, y is given like a 2x plus 5 to the power 3 is a function. So if you apply ddx 2x plus 5 is 3, actually there is a no such formula because this is not x to the power n, though it looks like x to the power n, but it's not exactly x to the power n formula. So what you can do here is that say z equal to 2x plus 5. Okay, once you assume this, so calculate z equal to this. So then what happens is that this differentiation now change to 2x plus 5 is taken as z. So z q. X to the power n is n x to the power n minus 1. When you apply that, but your differentiation should be, see, this is a variable is x and differentiation is ddx. So here again this is dx but this is z. So what we have to write is here is that d of dz here, and as zq function is there because zq can be differentiated with respect to z only, correct? So now okay, now instead of we have written, instead of dx we have written dz. So now we can write dz. You can get 3z square now dz by dx. So from here what you have to do, dz by dx means now ddx of 2x plus 5. So as we know that as per the summation law, this ddx can be applied here. So ddx of 2x and ddx of 5. So ddx of 2x 2 into dx by dx is 1 and this is 0. So this is basically 2. So dz by dx is 2. So now answer is 6 z square, and as the j at this z is the z was not given, so actually we have to replace with 6 2x plus 5 yes, this is the answer. But here what this is the discussion started with dy by dx can be written dy by dz by into dz by dx, so that we have applied here. Okay, so this way, and especially when in this point we have used, because we want to ddx cannot be done for z cube, so what we have to do, that we have to do that ddz and then dz by dx. So here this formula is used. Sometimes we say as a chain rule.